Let's find the area of this blue region. So we have this quarter circle and the full circle, and the intersection of these two figures is subtracted from the entire area. So we are left with these four separate blue regions. We want to find the area of that. So in order to do it, I would start with finding the area of the overlapping part. So this green area. So how do I find this green area? So this green area consists of two parts. So this triangular part and then this part. It's an up part of circle, but we can easily prove that it's a semicircle. So first, if you go to since this is a quarter circle, this side is 90 degrees. And since this is 90 degrees, you can say that this is diagonal of the circle, the big circle. That makes this part is semicircle. And that's like if you use the basically if you simply use the Pythagorean theorem, you can find that the dE, and half of that, the half of the dE is the radius, so radius of the circle. So we know the radius. You can easily find the area here and area here. So that's the area of the semicircle, PR square and half of it, and the area of the triangle. So area of the semicircle is P times R square, radius square, half. So the area of semicircle is 5 pi over 2. And the area of the triangle, so since this is 90 degrees, 2 times 4. 2 times 4 over 2. So the area of triangle is 4. So if you combine those two, so the area of this white area overlapping is the triangle plus the semicircle, 4 plus 5 pi over 2. So that's one information to keep on one side. Now let's find the radius of the quarter circle. What's the radius of the quarter circle? We know the radius of the circle, the small one, the quarter circle. You can easily prove that this BF is a radius of the quarter circle, and BF is exactly same as DE, because this makes, since this is 90 degrees, this will go to the, so the main argument here is that the fact that these two triangles are tangent here, the circles are tangent here. So this line BF should pass through center of both circles, this circle and then this circle. So that makes BF radius. So basically the radius of the quarter circle is equal to DE, which is 2 times square root of 5. So twice, it's basically the diameter of, so the radius of circle is R root of 5, and that's 2 root of 5. So we know now we know the radius of the quarter circle. So what we can do here, let's start by finding the area that's a part of quarter circle. So this red area. So we want to find this and then this. How do you find this? Imagine the quarter circle. So the area of this quarter circle is 5 times radius square over 4. So like 5 pi. So if you compute it, that makes like just 5 pi. I'm going to subtract it for this area. So we know the exact area of this white part. So I'm going to 5 pi minus 4 plus 4 pi, 5 pi over 2. So that's the red area. Similarly, we can go to this green area. So same way. So you can start looking at this green circle and then subtract from that the white area. So green is 5 pi minus this. So if you combine the green area and the red area, you will end up finding the total area. So that's total is going to be, so if you pay attention, this is 5 pi minus 4 plus 5 pi over 2. So green area and red area, they are equal to each other. So I'm just going to do like twice 5 pi minus 4 plus 5 pi over 2. So if you do the simplification, these two multiplies to this one, you need minus 8 and then 5 pi. Just simple algebra, simplify it to get 5 pi minus 8. So the area, initially we had this part, this one, these 4 areas, all combined together gives us 5 pi minus 8.